Hi friends, welcome back on another video of unsupervised learning. So today we will see customer segmentation using clustering, right? So basically this is the problem statement which is saying that there is a e-commerce company based in Argentina, right? And they have passed order detail which includes customer personal details like customer name, address, etc., and order details like order quantity, sales, product code, etc. Now the company wants to understand if there is any pattern among these customers and use it making more profit. They want to analyze the sales data with respect to customers and identify high yield groups of customers. So the objective basically here is we will use clustering techniques to identify the segment of customers. We will see if these groups are similar or different. We will analyze these groups and brainstorm about how this information can be utilized to make an informed business decision. So this is some insight about our data. Now let's start with doing step by step. First we are importing libraries. So warning used to suppress display warnings, right? And OS is used to provide a way of using operating system dependent functionality. We use it for setting working folder. Now pandas is used for data manipulation and analysis, right? Numpy is used for large multi-dimensional array and matrices along with mathematical operators on these arrays, right? Then we have is matplotlib is a data visualization library for 2D plots of array built on numpy arrays and designed to work with the broader scipy stack. Now importing matplotlib.pyplot as plt, and seaborn is based on matplotlib which aids in drawing attractive and informative statistical graphic, right? This is seaborn. Now scikit-learn features various classification, regression and clustering algorithm, right? So these we have. Now setting options, so here suppress display of warnings, ignoring all. Now display all data frames columns. Now pd.option.display.max columns, right? That is none. Then to set the limit to 3 decimals, so here we are calling this dot format. Now display all data frames rows, right? Here you can see read data. Now read csv file using pandas. Df equals to pd.read csv. Now sales data sample.csv encoding equals to unicode escape. Okay, now to display the top 5 rows of data frame, df.sample of 5. Now data analysis and preparation. Data preparation is the process of cleaning and transforming raw data prior to building machine learning models. Here we will analyze and prepare data to perform clustering techniques. Check dimensions of the data frame in terms of rows and columns. Check data types. Ensure your data types are correct. Now refer data definition to validate. If data types are not as per business definition, change the data types as per requirement. Study summary statistics. Now check for missing values. Univariate analysis and required imputations. Bivariate analysis and inference. Data preparation for model building. Note now it is an art to explore data, and one will need more and more practice to gain expertise in this area. To display the dimension of the data frame, now df.shape. Okay, to display the columns, name of the data frame, df.columns. So there are all the column. Now data types and summary statistics, so here df.dtype. So all these are the data type. df.info, pandas core.frame.data frame, right? All these things you can see. df.columns, so here you can see all the columns we have. There are many object types features like continuous variable, you can see here, discrete variable and categorical, you can also see here. Now the below output prints the important summaries, statistics of all the numeric variable like the mean, median, minimum and maximum values along with the standard deviation. So describe the numerical data. Here df.describe we are calling it. Now df.describe including O and transports, right? So here we are including O, and you can see count, unique, top and frequency we got from here. Now missing values, so missing values equals to df.isNull, right? and dot sum divided by length. This is to check for missing value, whether do we have any missing value or not. So here you can see this is the percentage of missing value. So here we can see in the above column, in this address line 2 is 89 0.3% of missing values, state has 52.6% of missing values, and postal code has around 2.69%, and territory has around 38% of missing values. Now univariate analysis, you can see status here. So sns.count plot df status, right, color equals to blue. So here you can see we will convert the labels of the status columns to 0 and 1 for shipped, assign value 1, and for all other labels cancelled, resolved, on hold, in process, dispute, assign 0. Note, we will consider everything apart from shipped as cancelled, so that will become our 0. Right now here you can see df status equals to df status dot map we are calling, and here we are mapping ship to 1, cancel to 0, resolve to 0, on hold to 0, on process to 0, and dispute to 0. Now if we called sns.count plot df status color equals to blue, so 0 and 1 you can see here, we will drop status column as it is a target and it may influence the clustering outcome. So here it is. Now convert order day to date time format. So this is again very simple. You need to just call pd dot to date time and just pass the order date, right? Then it will return this proper format of date time. Now country product line deal size, right? So here we are importing rc parameter, figure size in inches. So here we have figure sizes, we are passing 18/6. Now sns.count plot df country, so this you can see count of all and country respectively. From matplotlib import rc parameter, figure size in inches, rc parameter figure dot fig size 8:10:6, ax sns.count plot df deal size, right? So here you can see that deal size is here, count is here, small, medium, and large. Now from matplotlib import rc parameter, so figure size in inches, so rc parameter figure dot fix size equals to 12.6, right? Ax equals to sns.count plot df dot product line, and count you can see here, product line you can see here. Now we have one hot encoding categorical feature, so dff equals to pd dot get dummies, data equals to df columns product line, right? Deal size country, drop first equals to true, and dff you can see dot shape, right? Now dff dot columns we have, so here you can see continuous features, just a quantity ordered, right? Price each, and order line number, sales, and msrp that we have. So here you can see the relationship here, this plot we are plotting it, and sales on the basis of sales, right? kd equals to true, histogram true, color equals to blue. So this one you can see sales, right? And the histogram here. Now the box plot of sales, so if we see the box plot here, you can see are very less outlines, right? Outliers. Now sns displot dff quantity order, so kd equals to true, histogram equals to true, color equals to blue. So you can see it is slightly normally distributed quantity ordered, right? So again this is this plot for that. Now we can see that order are bulk order, majority of the orders quantity are between 20 to 40 units. It is quite uniform but skewed towards right side. Now sns.displot dff price each, kd true, histogram true, color equals to blue, right? So here you can see that the distribution of price is left skewed and with max price of 100. Now the majority of price is $100, right? So this way you can achieve it. Now sns.displot dff msrp, kd equals to true, histogram true, color equals to blue, right? So this you can see from here. Now sns.displot dff order line number, kd equals to true, histogram true, color equals to blue. So this way you can see here. Now bivariate analysis and multivariate analysis, sales vs month, right? Monthly revenue equals to, you can see here monthly revenue that we have, plot for x label, plot for y label, this is for title. So monthly revenue you can see that for month and the year 2002, 3, 4, 5 respectively. Now we can see that the revenue is growing in October and November. It can be the result of the festive seasons. We can see that the revenue is higher in 2005, right? Now sales versus countries, so plt dot figure size, fixed size 9 and 6, top cities, df dot group by. So we have country and sales here dot sum, and sorting values in ascending order. Now top cities.plt kind equals to, again, bar we are passing, and plt.title, that is top 10 countries by sales and country total sales. So you can see these are the country top sales, top 10 country by sales, right? Now correlation matrix, to get a correlation matrix, plotting correlation plot, you can see here. Okay, plotting the heat map correlation, give the correlation matrix. CMap color code used for plotting. The Vmax gives maximum ranges of values for the chart, right? Vmin is here, annote is here. SNS dot heat map correlation, CMap equals to, sorry, correlation CMap equals to, this is the color code we are passing, right? Vmax 1.0, Vmin, these are the minimum maximum. Annoting we are giving true, and annote KWS size of 12. So if we print our heat map here, so you can see that how nicely it is plotted on the data. But there are some observation like QTR ID and month ID have the highest correlation. Again, if you check the QTR ID and the year ID, right? So this is here, no, not year ID, it is month ID, QTR ID with the month ID. So here you can see 0.98 or 98%. Year ID and core order number have high correlation. So year ID and order number has the highest correlation here. There is positive correlation between sales price each, quantity ordered, right? Sales, this one, price each, this one, and quantity order. So if we check that, this one, right? So that is positive correlation. Now it is asking to plot pair plot. So simply we are using ilog dff, right? And on the basis of that, you can see all the column that are required have been printed here. Now df dot columns, it is again getting column, and now we are preparing our data for next clustering. So here we are calls to drop, these are to be dropped, right? Df final dot column, so here you can see these columns we have left. Now df final head, so if we get the values, so you can see now standard scalar we are calling from pre-processing for our pre-processing data. Now feature df dot final column, right? Sc we are passing the standard scalar, df scale, sc dot fit transform, f df final, data equals to pd data frame, df scaled column, df final dot columns, data dot head, right? So here you can see quantity ordered, price each, order line number, sales, month id, year and all. K-means clustering from a scalar dot cluster, import k-means, right? Using the elbow method to find the optimal number of clusters. So WCSS you can see also for I in range 1 and 15, k means n cluster equals to I init, right? You can see here maximum iteration 300, n init 10, random state 0. Now k means dot fit equals to data, right? WCSS append k means dot inertia, plot the graph to visualize the optimal number of cluster through the elbow method, right? So here plt dot plot range 1 and 15 WCSS, title the elbow method, x label number of cluster, y label WCSS, right? So everything you can see here. Using selected score, higher the value better the cluster. Earlier run suggested 3, right? Now from sklearn.matrix we are importing the Silote score, right? Passing the n cluster as 3, 4, 5, 6, 7. Now using the loop here to build the cluster, right? And random state creates the sample in the same order, okay? And fitting the predict on the scale data, then we will get the Silote score, and the function will compute the Silote score for each k, right? So here you can see these are the each k values, and this is the Silote score. Now run raw cluster algorithm. So if we get that, so it is again in k-means, right, and passing k-means plus plus. So here you can see max iteration and init, right, random state, and we are fitting the data, then getting the cluster centers. So this is, you can see the raw clusters. Now add a column cluster in the data giving cluster number corresponding to each observation. So we are passing the cluster number here, right? So if we slide it here, so at the last you can see from which cluster it belongs to, right? Now df final cluster dot value count. So if we again count the values, so all the values are here, getting the summary for observation in the cluster. So df dot final equals dot cluster equals to 0, right? So dot describe we are calling, so here you can get the describe function. Now sns dot box plot df final cluster df final quantity ordered, right? sns box plot df final cluster dot df final price each, right? So this is for box plot. Now sns dot box plot df final cluster df final sales. Okay, so here the sales values we have. Now sns box plot df final cluster df final msrp we have here. pd dot cross tab df final cluster, right, df final for month id. Okay, now pd cross tab df final cluster df final for product line ship. So this is for that. Now this is for deal size small, right? And finally we are applying hierarchical clustering here. So z equals to linkage data word, matrix equals to Euclidean, z shape if we get that. Now plt figure size we are passing, dendrograms equals to again z, and plt dot show. So here you can see that how the hierarchical clustering is defined here. Now dendrogram, so basically z truncate mode equals to last p, so it will basically show the last p merge cluster, right, as we also discussed in the last videos. Now p equals to 20, so that means show only the last p merged cluster in it, right? Now dendrogram, again the same thing we are doing, but here we are passing p as 6. Okay, so here you can see the p as 6, so this way we have this hierarchical cluster. Now let's import the distance and hierarchy, right, to get the final coefficient, right? So matrix of original distance between observation and matrix of coefficient distance between observation, right? So coefficient, now coefficient, so if we get that, you can see that we are getting it 58%. Now we can see at least 5 and 6 distinct clusters. So what we'll do is we will now generate cluster level. So sklearn.cluster import agglomerative clustering, right? scipy dot cluster import hierarchy, cluster equals to agglomerative clustering, and clusters equals to 6, affinity Euclidean, linkage word, right, everything is there. Now label hc cluster dot fit predict data, df final label equals to label hc df final dot head 2. So everything you can get it from here. df final label dot value count, so if we count that, so here you can see 312054, everything is there. Now conclusion and inferences from k-means clustering, we are getting 6 cluster here. The cluster 0 and cluster 1 are much bigger than other 4 cluster, right? From the dendrogram, where it seems to be 2 kinds of data, we can find 4 groups from the dendrogram. If we remove the highly variable data which is merging towards the end of the agglomerative clustering model, cluster profiling based on k-means clustering, and these results may vary based on the random state, right? Cluster 0 highest customers in this group buy item in the high quantity, the sales amount is also on the higher side, and the mean price of each item is also to 99, so they are the highest buyers of the product with the higher msrp. Now cluster 1 equals to this group represent customers who buy items in varying quantities 30, right? They tend to low price item that belongs to 68, and their sales are 2061, so they buy predict with lowest msrp here. Now cluster 2 3 4 5 that we just seen above have quite similar properties. We need to analyze them deeper to understand their pattern of purchases. So you can also go with the detailed of this notebook, right, and see whether it is solving your problem as well. So this was all about this lecture. So we'll come up with next interesting video. Stay tuned. All the best. Have a good time.